Hello, welcome to another tutorial for Unreal Engine made easy. Let's go. In this video, we'll learn how to make fields that can scale up to any size and grow during gameplay. This could be used for crop fields for farming, landscape grass, or really any mesh that you want. And this can be used in any type of project. For our demonstration here, I'll use this static mesh to create a wheat field to grow. This is a free asset that I've linked in the description if you want to use it for yourself as well. So first off, we want to create a field of wheat. But we don't want to have to manually place in dozens of meshes to create a large field. So we'll start by making an actor blueprint for this. Name it, open it up, and we'll add some logic within the construction script to create the fields automatically. First, we'll need to add an instance static mesh component. So add that to the hierarchy over here on the left. And then add the static mesh that you plan on using over here in the details panel for the component. So we'll add this wheat mesh for our demonstration here. Now we need to add some variables to generate our field here. Start with two integer variables. One will be named rows and the other one named columns. This will define basically how large the field will be. And next we'll create two float variables, named one spacing and the other one named initial scale. This will determine how much space is between each of our meshes, and then we'll store the starting scale for us to reference as they grow. And for convenience, you can go ahead and set all of these to instance editable as well by clicking on the I symbol next to each variable. Now we can start our logic in the construction script. Drag the instance static mesh component into the graph. Pull off from here and search for the clear instances node to make sure that we're starting off with a clean slate each time this rebuilds. After that, create a for loop node. Get a reference to our rows variable and subtract that by 1. Then hook this up to the last index pin of the for loop, and the value for the first index can just stay at 0. Now we're going to create another for loop node. This time we'll get a reference to our columns variable, subtract that by 1, and hook it up in the same way. And this second for loop node will hook into the loop body from the first one, just like this. Now pull off from the index from our first for loop and multiply this by our spacing float variable. And then do the same exact thing for the second for loop as well. Then create the node makeVector. The multiply result from our first for loop will hook into the x value, and the result from our second for loop will hook into the y value here. So take the result of this makeVector and then get a makeTransform node. We don't need to worry about the rotation unless your mesh has an offset that you need to account for. But here's where we can get our initial scale variable and then create another makeVector node. Plug the initial scale into the x, y, and z of this node, and then hook this up into the scale input of the makeTransform node. Now we're generating a grid of locations for our wheat meshes, so the last thing that we need to do is spawn them. Drag in another reference to the instance static mesh component or use your one from earlier and search for add instance. Then just plug in our makeTransform node into the instance transform here. That should be everything that we need for generating the fields, so let's test this out by dragging one of our field actors into the scene. Now we can adjust these variables that we set as instance editable, and then we can see what happens. First of all, we want to turn down the initial scale to be pretty small since they're going to grow and get bigger, so maybe something like 0.1. Now you can plug in some numbers for the columns, rows, and spacing. We can adjust all of these values and see the results in real time since we created the logic within the construction script. So now you can easily create fields of whatever size you want just by changing these values of the rows and columns. And you can make them more dense or spaced out by adjusting the spacing variable. You can of course play with these values however you want, but we'll just set it at 10 by 10 by 10 for our demonstration here. So next we'll create the logic for the fields to grow during runtime. Back into the fields actor blueprint, and we'll go to the regular event graph. First create a timeline, name it, and then double click to open that up. Within the timeline, we'll click the add button here and create a float track. Name it grow alpha. Make the length something like 8 so we can create a steady increase along the timeline. Right click in the timeline, add a key, and set it to 0 time and 0 value. Then add another key and set the time to match the length of the timeline, which we set as 8, and make the value 1. So now basically we'll have a steady growth rate. This is good to go, so head back to the event graph. Now pull off from the update pin and add a for loop. Drag in our instance static mesh component, and now we can search for get instance count since it has already created the instances for the field within the construction script. Subtract that by 1 and then plug it into the last index pin of our for loop. Again, the first index can just stay as 0. Now from here, pull off from our component reference again and search for get instance transform. The instance index value here will be our index pin from the for loop node. Now we want to increase the height of our wheat meshes to make them grow. So right click on the transform and split struct pin. Do this again on the instance transform scale, and now we have access to the Z scale value. Pull off from this Z scale value and create an addition node. Set this to something really low, like 0.002, and then we can right click and promote to variable and name it growth rate. Go ahead and make this instance editable too, so that we can control this conveniently like the others as well. So now we need to add a lerp node here so that the values will steadily change along with the timeline. The A input will just be the regular transform scale Z. The B input will be the result of our addition node here. And then the alpha input will be the grow alpha value from our timeline. Now all of the math is done, and we just need to set the updated transform values for the meshes. So pull off from our component reference again and search for update instance transform. The transform location, rotation, scale X, and scale Y will all just be directly connected from the get instance transform node. But the transform scale Z will hook up to the result of our lerp node. The instance index will be the index pin from the for loop node. Awesome, so now all we need to do is attach the play from start node on our timeline to initiate the growth mechanics. For our demonstration here, we'll just hook it up to the begin play, but you could hook this up to a custom event or function if you want to trigger it at a certain time or however you'd like. Let's play an editor and we should see the results in action. Nice, so we can see here that our wheat fields are definitely growing. Very cool, so now we have crops growing during gameplay. Hopefully you can see how this all works, but before we wrap up the tutorial, I'll quickly show how you can further customize the setup. So the growth rate variable will control how much height is being added to the meshes during each tick of the timeline, but it does not adjust the actual length of the growth cycle. That is determined by the length value that we set within the timeline. So if you want the growth cycle to be twice as long, for example, we could adjust this value from 8 to 16. And then also adjust the time value of our second key in our graph here from 8 to 16 as well. And if we also adjust the growth rate variable to be half of the previous amount, they will grow to the same height over the slower growth cycle. So now if we play an editor, we can see that the fields will have a growth cycle of 16 seconds instead of just 8. And since we adjusted the growth rate variable along with that, it's more slow and steady now. So that's how you can adjust the overall time and rate of the growth period. Looking good. Alright, so but what if you want the fields to regrow? Say for example the fields grow and then they get harvested or they go out of season. You could just put the timeline to looping, but then it'll just constantly reset without any time in between. So we'll have to reset the scale of the meshes and then restart the timeline manually. So let's create a custom event to trigger the reset of the growth cycle. You can just grab all of this from the update portion and then copy and paste. Just change this part here at the update instance transform. Remove the lerp for the transform scale Z and instead just replace it with our initial scale variable. This is the logic for resetting the meshes back to their initial scale. So for a quick demonstration of this, we can just pull off from the finish pin of the timeline, apply a delay which would simulate maybe the harvest period, and then hook this up. And now we should have a repeating growth cycle. Let's play an editor one last time and see if everything is working. Alright, so we'll see them grow as usual, and then after they finish growing, here's where we have the delay in place, which is simulating maybe the harvest period. And then there we go. Now we can see that the growth cycle is resetting. Perfect. So once again, you can customize all of these values and trigger the growth cycles however and whenever you want. You could easily change the custom event to retrigger the growth cycle to an interface event and then call that from anywhere. For example, in my indie project, I have a seasonal cycle going on within the game, which triggers a growth cycle along with that. So I hope you found this helpful, and now you can apply this into your own projects. Thanks for watching this video. Feel free to let me know in the comments below if you have any feedback or questions. And check out my channel here for more tutorials, tips, and information on Unreal Engine made easy. See you in the next one. Thanks. Peace.